This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Well, I'm making some hypobromous acid. You can see by the top equation, bromine plus water. The bromine disproportionates, meaning it goes up in oxidation and down in oxidation. You can see it makes HOBr and HBr. Now the Br2, they're sharing, so they're at zero, they're neutral. Say HOBr, it's a +1 for the Br. HBr, it's a -1 for the Br. So you can see the two Brs were at 0, one went up to +1, one went down to -1. Okay. Now, if you saw my bromine video, you've seen that there was clumps of, I don't know if it's polymerized bromine, or maybe it's a combination of bromine and chlorine that polymerized, made some oligomers or trimers, dimers, whatever. I don't know what it was. I didn't get it out. I just dumped it all into the water, as you'll see. And so I don't know exactly. I know there was 40 milliliters of bromine there, but there was a little bit of water in there. Not enough to form two layers, but still there was some water in there, and there was the solids. The nice thing about putting the bromine in water, and you can see the picture here, is it's very dense compared to water. It all sinks, all the excess things sinks to the bottom. It kind of is capped by the water, you know what I mean? So it can't get out. You can contain it a lot easier. You can see the green there, that's showing you the solubilities of bromine and water at each temperature. So I have an idea, when I use it for an experiment, you know what I mean? I know 41 grams is in a liter. But here's the deal. I had 40 milliliters. Even if 10 milliliters were solid, I still had 30 milliliters. 30 times 3, I don't know what the density of bromine is, but I think it's like 3.1 or something, like, I don't know. But it's at least 3, so that's 90 grams, right? Now the solubility is at 0 degrees Celsius, is 41.7 grams per liter of water. I put in a liter and a half. So that means I need only 62.55 grams can go into that liter and a half water at 0 degrees Celsius. I have 90 grams. So that tells me that the water is saturated with bromine. You can't get any more bromine in that water, okay? So when I pour it out, let's say I want 20, I'm doing an experiment and I need 20 grams of bromine, right? I know at 0 degrees, there's 41.7 in a liter. So if I took a half a liter, I'd have approximately a little bit over 20 grams, right? If a full liter is 41.7, half is at least 20, right? I want you to keep in mind, when you do add this to a double bond, it does not give you a dihalide. It gives you a halohydrogen. Okay. I want you to look at the top there where my shadow is pointing. And we're going to go to this, to this. Here's your double bond, right? There's your bromine. Now remember, bromine, each bromine, they're equal. You know what I mean? There's no positive or negative. But as it comes over to this negative electron density here, that double bond, this negativity is going to repel electrons on this side of the bromine over to here. And you can see I have the negative here and the positive here. And what happens when you got a negative and a positive? They react. So this electron density jumps off, grabs this bromine, and throws that bromine out. So you have a positive bromine on here. You see, here's your propane, or propene, and the double bond split up to make a bromonium ion. Okay. Then, if you have no water, this negative bromine will come up and do an SN2, and open up this helonium ion, whatever you want to call it. And you will have a Br and a Br. But, hold on. Anyways, it goes up to the middle there. Opens up the whatever, and you have two BRs, a dihalide. But what happens if you have water? This would go to this, which is the same as this, right? These two are the same thing. You got your bromonium ion. Now, OH negative is a better nucleophile than Br negative. So if you got a choice, see this one you didn't have a choice. You only had bromine. You had no water. Here you have a choice. You got a better nucleophile. Okay, and a nucleophile is just something negative that's looking for something positive. Why does it go to the middle one? Why doesn't it go to this end one? There's less steric interference. You would think maybe it would go here, but it doesn't. It always goes to the harder place to go. You know what I mean? And the reason why is because this is positive. And where can positivity be stabilize it? Like, if you have your positivity at the end here, you have no inductance except from this one carbon. But if you put the positivity on the middle, right, on the middle carbon, you have inductance from this carbon and this carbon, right? And not only that, maybe hyperconjugation from the hydrogens on the end carbons. You know, they're helping to stabilize that positivity more than here. Because if you're on the end, you know, if you're a carbon that's on the end of the chain, you only have one carbon. If you're in the middle, you have two carbons, one on each side. And also those carbons have hydrogen, so that they could help too. Inductance, hyperconjugation. And then you end up with your halohydrin. And that's basically all I wanted to do, and that's why I'm making styrene on the next video. My ban is up. I got banned. My last video got banned on the 23rd of January. 3 months is up on the 23rd of this month. I actually wanted to put the styrene video up now, but I checked and I can't until the 23rd. I don't want 2 banned videos within a 3-month period. But I want you to keep in mind, because half of it is going to be turned into HBr, that a double bond plus HBr, you will protonate it, make a carbocation on the most stable carbon, which is the secondary one right in the middle, and your bromine will add there, your hydrogen will add there. And then I took the hydrogen off because, you know, it's still there, it's just why I write it. And this is what you would have. So you will have byproduct of this at least a little bit, right? Color titration. You know, when you titrate something, I'm sure you've seen videos where they use the one thing that turns pink when it's, you know what I mean, you keep adding until you see the color change, and then you know it's neutralized. And that's the end of your titration. Well, this does the same thing. If I'm using this HOBr on, say, a double bond, and I drip it in, drip it in, drip it in, now if as I do that, the red color will disappear as I drip it in, because it will almost immediately react with that double bond, right? Making a halohydrin. But how do you know when you're done? Well, when you drip it in, and it'll take longer and longer for that red to go away, right? And eventually you're going to drip it in, and the red will never go away. And the reason why it'll never go away is because your reaction is done. That's how you know you're done. But I have an idea of how much is in there, you know what I mean? And then I would use to get a volume that I need, you know, that's close to what I need. And then when I do the actual experiment, I can just color titrate. When it stops turning clear and it remains red, the experiment is over. The reaction is over, okay? That's basically it here. I'm going to show you the video. It's a short video. All I'm doing is basically putting some bromine into water. Even though this has nothing to do with the video, I'm going to go over my subscribers. I don't understand. Up until now, my subscribers have gone up, pretty good, at least the way I want them to. Not as good as I see they are for other chemistry channels, but still within my goals. I noticed this last couple weeks, I got more people, well, not more, I got about the same amount of people. So I usually get 2 or 3 subscribers a day. Now I get 2 or 3 subscribers a day, but I'm also getting 2 or 3 subscribers that are canceling. So I don't know what the deal is with that. I see other, like my arch nemesis video where I'm showing the 3 other people that started about the same time I did, and they're all friends of mine. They're all getting double the subscribers, and they're having like 1/3 the videos. Maybe that's my problem. I'm putting out too many videos. I don't know. Anyways, I never ask people to subscribe because it's, I see videos that's so annoying when somebody asks you to subscribe 3 times in a 15-minute video. But this is the first time I'm actually going to say it, and I'm going to ask. I don't get paid for it. I mean, basically, it just makes a person feel good. That you don't get paid for nothing. I mean, unless you turn on your thing for YouTube, and even then, you only get paid for views. You don't get paid for subscribers. And even a lot of the views you don't get paid for. You only get paid for the views where they actually watch the commercials. But it does make me feel good. You know what I mean? If my subscriber, it doesn't make me feel good when I see 3 people subscribe and then 3 people unsubscribe during the same day. That's, you know what I mean? So anyways, this is my little begging thing. Please subscribe. And that's pretty much it. I just wanted to remind people this too. At the beginning of my videos it says forbidden video. And I do know that forbidden is spelled wrong. I originally did that as a mistake, and then I didn't have time to change it, and I just put it up there. And then weeks later, I actually did make another video to change it so that it was spelled right, but I left it in there because I want people to realize that, these are 15-minute videos. I'm learning myself. You know what I mean? I'm not perfect. And that's what that misspelling of forbidden is basically, that's the purpose. To show people that, hey, people make mistakes, and if you're going to do anything or repeat anything that I do, maybe you should ask some questions or whatever, you know what I mean? So I do understand that it is misspelled, and I'm leaving it there on purpose. I don't want people to think I'm a total idiot, though, and that's why I'm bringing it up again. But it is there for a purpose. It's to show people, like I said, that I am human and I make mistakes. So, if you're going to repeat anything as serious as chemistry, you need to not just watch a video, you need to ask some questions too. But y'all have a great day, and also remember that science is great.